So in this lesson, I'm going to go over the concept of significant figures, which you were introduced to in the worksheet that you were working on before. Really quickly, I'm going to go over the rules and how to count significant figures. And the way that I teach it is using a trick of the United States. Now, looking at the United States, the ocean that's on the left-hand side would be the Pacific Ocean, and the ocean on the right-hand side would be the Atlantic Ocean. And so what I say is that if the decimal place is present, then you are going to be counting from left to right. If the decimal place is absent, then you're going to be counting from right to left. Now, one other rule that you need to keep in mind, you cannot start counting on a zero, but once you start counting, you may count zeros. So let's look at a couple of examples to make sure we understand this. If you look at 609, 609 does not have a decimal place. Therefore, the decimal is absent. So I'm going to start counting on the first number that's to the far right, which is your 9. I can start counting on a 9, so 9 is 1. I can count that 0 as a significant figure because I've already started counting at this point, so that would be 2. And then the 6 would be the third significant figure, so there are a total of 3 sig figs. For the next example, 0.02, because there is a decimal place, I'm going to be counting from left to right. So I look at that first 0, and I know that I cannot start counting on a 0, so I'm not going to count that 0. I'm not going to count the 0 in the 10th place, but I can count that 2, and so I have one significant figure. So what I want you now to do is to refer back to the significant digits and measurements activity that you completed in the last class and determine what the relationship is between how precise measurements are and the number of significant figures they have. So pause this video right now and come to a conclusion. So what you should have realized is that the more precise a measurement is, the more number of significant figures it has. So in this class, we'll be working with measured numbers, but we'll also be working with exact numbers. Now, exact numbers are obtained by counting or using the definition that compares the two different units. And when we're dealing with exact numbers, we do not count significant figures, only when we're using measured numbers. So as practice, decide whether each of the following is a measured or an exact number. So here, 1 liter equals 1,000 milliliters. Since that is comparing two different units, that is going to be exact. In this case, if I give you just 3.4 grams, that would be measured because you're not counting and you're not comparing two different units. The next thing that we're going to be talking about and what we're going to be using throughout this class is significant figures and calculations. So whenever you complete a calculation in this class, your final answer is going to have to be rounded. And the way that you round it is based on either significant figures or decimal places, depending on what you are doing in your final calculation. So if your final calculation is multiplying or dividing, the number of significant figures is going to be the same as the measurement with the fewest number of significant figures. So let me give you an example. If you look at example A, 4.56 has 3 significant figures, 1.4 has 2. And so when I multiply those together, the answer I get is 6.384. Now I need to round that answer, and I'm going to round it to 2 significant figures. And so my answer is going to be 6 point, and then the tenths is what I need to round to. So that's going to be rounded to 6.4 because that's 2 significant figures. For example, B, 298 has 3 sig figs. 8.315 has 4 sig figs. And so when I divide, I end up getting 35.8388, and it continues on. Well, since 298 has 3 sig figs, that's how many sig figs I need. And so as a result, I'm going to round this to 35.8 because that has 3 significant figures. Okay? Now, that's if the very final step I complete in my calculation is multiplication or division. If the final step is addition or subtraction, then the final answer should have the same number of decimal places as the measurement with the fewest number of decimal places. And so that's the number of digits to the right of the decimal point. If instead of being rounded to the tenths or the hundredths, your measured value actually is rounded, let's say, to the tens place, then you would need to round your final answer to the tens place, but we rarely deal with that. So the rule I'm giving you right now is simply count the number of digits to the right of the decimal point just to make it a little bit easier. So let's look at that. How many decimal places does 186.1203 have? Well, it has 4 decimal places. 2.04 has 2 decimal places. So when I add those two values together, I end up with 188.1603. So my final answer is going to need 2 decimal places. So that's going to round to 188.16. For the subtraction, 58.266, that has 3 decimal places. 1.1 has 1 decimal place. And so when you subtract, unrounded, it's 57.166. So I want just 1 decimal place. So it's going to be 57.2. So the exception to that rule, as far as digits to the right of the decimal point is concerned, if, for example, in example A, instead of giving you 186, I had given you 190, notice that 190 is rounded to the tens place. So your final answer would be 190 as well, because that's rounded to the tens place.